Hey everyone, welcome to my YouTube channel. This is Lolita studying in Sri Venkateshwara College of Engineering in the department Computer Science and Engineering. Today I am going to discuss about the topic solar energy in the subject Introduction to Mechanical Engineering, subject code BESCK 104D. Introduction to solar energy. Solar energy is produced by the sun and is the most abundant source of energy available on earth. It's a renewable and sustainable source of power. The sun continuously emits vast amount of energy in the form of sunlight, and harnessing this energy has become a crucial part of global efforts. The sun is a massive ball of gas that produces energy through a process called nuclear fusion. This process releases energy in the form of heat and light, which can harness through solar panels. Applications of solar energy. Here we'll get to know the uses of solar energy. The solar energy is used in solar cooling, solar water heating, solar electricity which is thermal, and solar electricity which is photovoltaic, solar drying, and solar desalination. Types of solar energy. Basically, there are four types of solar energy: passive solar gain, solar thermal for heating, concentrated solar power for electricity, solar photovoltaic. Solar panels. Certainly, solar panels, also known as photovoltaic panels (PV), are devices that convert sunlight into electricity. Here's some information about solar panels. Efficiency. The efficiency of a solar panel refers to the percentage of sunlight it can convert into electricity. Higher efficiency panels are generally more expensive but can produce more electricity in limited space. Installation. Solar panels are often installed on rooftops or in open areas where they can receive maximum sunlight exposure. The angle and direction of installation are important factors affecting their performance. Inverters. The electricity generated by solar panels is direct current, but most household appliances use alternating current. Inverters are used to convert DC to AC, making the electricity compatible with the grid and home appliances. Net metering. Many solar panel systems are connected to the electrical grid. Excess electricity generated during sunny days can be fed back into the grid, and the user may receive credits or compensation for this surplus energy through net metering programs. The components of a solar panel system. A solar cell is made up of two layers of silicon, each specially treated to allow electricity to flow through it. A solar panel is composed of many solar cells. A solar array is a collection or multiple of solar panels that produce electricity together. Photovoltaic or solar photovoltaic helps in generating of electricity from sunlight's energy using PV cells. Now that you understood the components, let's dive into the working mechanism. Solar power plant. A solar power plant, also known as solar farm or solar park, is a large-scale facility designed to generate electricity from sunlight. It consists of an array of solar panels or solar modules that capture and convert sunlight into electrical energy. The primary components of a solar power plant includes solar panels. Photovoltaic PV modules or solar panels are the key components that convert sunlight into electricity. These panels are made up of semiconductor materials such as silicon, which generate a flow of electricity when exposed to sunlight. Inverters. Solar inverters are used to convert the direct current generated by the solar panels into alternating current, which is the standard form of electricity used in homes and business. Mounting structures. These structures support and position the solar panels at an optimal angle to receive sunlight. They can be fixed or tracking systems that follow the sun's path throughout the day. Electrical components. Various electrical components including wiring, transformers, and switchgear are integrated into the solar power plant to manage the flow of electricity and connect the plant to the electrical grid. Monitoring and control systems. Advanced monitoring systems are employed to track the performance of the solar power plant, monitor energy production, and identify and address any issues promptly. Solar power plants can be either grid-tied, where they are connected to the existing electrical grid, or off-grid, providing electricity to remote areas without access to a centralized grid. These plants contribute significantly to renewable energy production and play a crucial role in reducing reliance on fossil fuels and mitigating climate change. Advantage of solar power plant. Renewable and sustainable. Solar power is a renewable energy source, relying on the sun's energy, which is abundant and inexhaustible. Reduced greenhouse gas emission. Solar power generation produces minimal greenhouse gas emission, helping to mitigate climate change and reduce air pollution. Low operating cost. Once installed, solar power plants have relatively low operating and maintenance cost, especially in comparison to traditional fossil fuel power plants. Energy independence. Solar power reduces dependence on finite fossil fuels, contributing to energy security and independence for countries. Grid stability. Solar power plants can enhance grid stability by diversifying the energy mix and providing electricity during peak demand periods. Disadvantage of solar power plant. Intermittency and weather dependence. Solar power generation is dependent on sunlight, making it intermittent and influenced by weather conditions. Nights, cloudy days, and seasonal variations can impact energy production. Land use concerns. Large-scale solar farms may require significant land area, potentially leading to conflicts with agriculture or natural habitats. High initial cost. The upfront cost of installing solar power plants, including solar panels and associated infrastructure, can be relatively high, although these costs have been decreasing over time. Energy storage challenges. Storing excess energy for use during periods of low sunlight can be challenging and often requires additional technologies such as batteries, which can add to the overall cost. Resource and material use. The production of solar panels involves the use of certain rare materials and metals, and their extraction and processing can have environmental social impacts. I hope you all understood and gathered few useful information about the topic solar energy. Thank you guys for watching the video.